In this problem, we have a construction company with 1,200 feet of chain link fencing to be used to create 2 storage areas. The storage areas are to be laid out in a pair of rectangles that are adjoined, and the lines here each represent where fencing is necessary. So presumably there's some structure over here that they're building up against so that we don't need to fence this far left side. We're asked to find an area function that describes the total area as a function of one variable, and we're asked to define our variable. And then we're asked to find the domain of our function. So the answer to this question is going to be some sort of a function that describes area. So I'll use a of x as the name of my function, a representing area, and x is my variable. You can use any letters you like here as long as you understand what you're doing and you're consistent throughout the problem. The x, again, is the independent variable, so this is something that we can pick, so something that varies from one setup to the next. And then the area will be the total area of the combined space. So there's a couple of choices you could run with for x. We might choose x to be the distance along this side, so the number of feet of fence used on the 3 pieces. Each of these will be the same. Or we could let x be the distance down this right-hand side, the long distance. Or presumably we could let it be one of these pieces, assuming that the second one's the same size. One thing you want to be careful about, though, is that the length of this side does not need to necessarily be the same as the length of this side. These are rectangular areas, and so the 2 sides might not match. So there's more than one right answer to this. I'm going to work out one of the possible solutions, and I will choose x to be the length of this side. So I'm going to write up here, let x equal the length of the side shown in feet. So I'm referring to the graph here. So x is going to be the length of the side shown. And notice, if that's the length x, then this will be the length x, and this will be the length x. Now we're looking for the area of this resulting structure, and presumably we need to use all 1,200 feet of this fence. So what we need to do is determine how long this side is in terms of x. The overall area of this rectangle then will end up being the width here times the total length here. So my answer is going to be x times something, where this something is yet to be determined, and that's the distance that we would put along this side. So if we think our way through this, if I have 1,200 feet of chain link fencing, and I'm going to use x here, and x here, then this is going to be the rest of it. So for example, if I used 100 here for x, then that would mean I've used up 300 feet on these 3 sides. And so this remaining would be the 1,200 feet less the 300 that I've used. If you run through a couple of examples there, you can quickly come to the conclusion that this side's going to need to be 1,200 minus 3 times x. One possible way to discover this, if this didn't jump out at you, is we could let the length of this side be y, and then I'll note this down here, that x plus x plus x plus y needs to be 1,200 feet. And then I can solve this for y. Alright, simplifying this equation a little bit, I see 3x's plus y needs to be 1,200, and then I can solve for y and determine that y must then be 1,200 minus 3x. Alright, which is the observation that we made by thinking our way through the arithmetic that would lead to this. So the total area of the rectangle as a function of the one side is x times 1,200 minus 3x. And notice this is turns out to be a degree 2 polynomial. So the graph is a parabola. The leading coefficient will be negative, so this will be a downward opening parabola. And those sort of observations are necessary to answer questions that might come up about this fencing project. But in terms of the question asked, find the total area as a function of one variable, we have done that. The only thing left remaining for us now is to find the domain of our function. And this has a practical side to it, this domain does. There are minimum size on our value of x. Since x is a distance, x cannot be negative. So x is going to have to be greater than or equal to 0. Equal to 0 might not seem to make much sense, but technically the formula does work there. If I put no fence along this side, then all 1200 is going to be in one long straight line, and so there will be no resulting area. The area will be 0. And if we check our function at x equals 0, we see that we do get a 0 out. So I'm going to put equal here as a possible value for x, with the understanding that this function does work when x is equal to 0. It does not work when x is anything less than 0. This will return a value, but it's not possible to have a negative value for x, so the meaning of that value would not be an area measurement. The question we've got left remaining now is there an upper bound on x? And in problems of this sort, occasionally you will have them, and occasionally you will not. So we need to think about, is there a maximum value for x that could be put into here? And if you think about that, there is. I can't put 1,000 feet on this side. If I put 1,000 feet here, then I need 1,000 feet in the middle and 1,000 feet on top, and that's 3,000 feet of fence, and I don't have that much. So the question is, how far could we push x?